Hello and welcome to everyone listening to my session. I appreciate your time joining my session, and I'm very glad that I had the opportunity and invitation from the conference organizers, and I would like to thank them to having me in this great conference among a lot of great speakers with the quality sessions, and I will hope that you will enjoy them. And getting back to my topic, I'm going to speak today about the hidden gems of Java 19. And actually, I'm going to highlight some preview and incubator features for pattern matching, for switch expressions, record expressions, and the most importantly, virtual threads, structured concurrency, and the Vector API, which was there for a long time. And also a selection of small enhancement plus thousands of performance, security, and stability updates that definitely I will not be able in short period to cover all of them. So we're gonna see what are the most important parts that we would like to know about, but don't worry, you will not miss them because I write usually for Java Magazine. So you will have a link when I share my presentation with you after the session by the organizers. So you will have a link to those two articles that explain in details the main JIPs, Java enhancement proposals, and the second one, companion one will contain all the small features and details about enhancement, security, and stability updates coming with JDK 19. So you will be aware of all the additions that will make your life easier when you are coding using the latest version and features. So my name is Mohamed Taman, and I'm gladly happy to join Java Stage. And I'm working as a solutions architect for Nortel Serbia, and I'm the consultant, also architect for ananas.com.rs, which is Serbian e-commerce platform. I'm Java champion and I'm international speaker, so this is why I'm here and glad to be here to speak to you, sharing my humble knowledge. As I told you, I'm frequently, this is few of my publications. I write for Java Magazine mainly these days. So those two links, as you can see here, are the links for the full article discussing about this. So how to reach me, you can reach me on my social media, or much easier, just Google my name, Mohamed Taman, and you will find all of this. By the way, all the applications and proof of concept that I do, I share it on my GitHub account. So please, if you like any project, just start it, and you will find always that I'm updating my application to the latest version. Either it's Jakarta EE or Spring Boot applications, and as well as the Java. So all my applications almost running on Java 20 now even. So you are welcome to have discussion or comment or anything. Let's jump ahead to our presentation. So to see our agenda. So today we're gonna have some a little bit introduction about our JDK 19, what does it include, and what we have to figure out and check out. We're definitely gonna check out about Project Amber. You know that JDK comes with a project, and each project has a target to targeting some features and mainly some parts of the JDK to be enhanced in that specific area. So Project Amber actually is focusing mainly on the compiler and the language enhancement. And we're gonna speak about Project Loom, which finally long-awaited project to be introduced in JDK 19. And we will have it that, deliver for us for the first time virtual threads and structured concurrency. And we definitely will have to talk about Project Panama, which include Vector API and foreign memory and, such kind of APIs. And beyond that, those are the core features that coming and targeted and announced always with the JDK as the main features, but the hidden features that we're gonna explore some improved APIs and other stuff. And finally, because we are always love to migrate, so we have to know what has been removed, what has been deprecated, and what the changes happen and limitations. So we are not, cutting or pulling our hair when we do the migration. We have the knowledge, we know what to do, what to search for, what changes happen. So it will lead to smooth, migration. So a little bit like small history about Java, Java 19 has 7 main JIPs, as you can see, which is actually lower count than the 9 JIPs introduced in Java 19, Java 14, and Java 17. Also, the 17 JIPs in Java 16 and 14 JIPs in Java 15. As you can see, they have many, but in Java 19 we have less. But however, focusing on the quantity does not tell the story of the Java 19, which contain extremely important JIPs for the future-looking Panama, Amber, and Project Bloom, as well as porting for the GDK to the Linux RISC-V instruction set operating system. So this is very important to know that, yes, we might have less and fewer, but these are because they are big and features, and we have to consider about this. This Java 19 is a successful 6 months release cadence, and it's already has been announced since last March. And we have Java 20 September, I mean, sorry, and we have Java 20 came into March, and we will have the next LTS Java 21. I will write about it soon in September. So this is the really hot news and very good opportunity to get in touch if you don't get into Java 19 for now. So let's now speak about Project Amber, and this is one of the most important project that I consider very interesting for most of the developers. Because we like to know and to learn about Java. Actually, Project Amber, we have 2 JIPs here, 405 and 427 as the 2 main JIPs coming from under the umbrella of Project Amber, which focuses, as I told you, on a small Java language features that can improve developers' everyday productivity. So now let's see. As I told you, let's start with JIP 427, pattern matching for switch. And actually, it was first preview in GDK 17, as you can see in this legend. And it has 2 rounds. Second round, it was GDK 18, and this is the 3rd preview in GDK 19. And pattern matching for switch, this feature that has already gone through 2 rounds of the preview, as I told you, and first appearing in Java 17, allow us to write a code like this. And as you can see that we have here, we can switch over the inheritance case and the type of the pattern type. And also we have some more enhancement that we can check about the properties of that pattern type. So here we can say that if this object is type string, and if it yes, then also cast it and assign it to variable s, and then check about the length. If it's greater than 8, do something, and if it's only string, do something else, and if it's integer, do something else, and so on. But there is like readability enhancement you'd like to speak about, which is and this is somehow, it was for the developers, it's not clear and it's not right place to put it like this. So regarding this feedback, to improve readability of this feature, Java 19 changing the syntax to include a keyword is called when. So the new form of the switch pattern matching for switch expression here that we can use when. So it will be read like this, like case string, and if it yes, the case when also is dot length greater than 8, do the following action. And I would like just to mention that when is a contextual keyword, therefore it has no meaning except inside the switch. So if you are using variable called when, if you have using method with the name when or whatever it is, it will not be considered a keyword. So it just only used inside and has a meaning inside the switch expression. Same like the word default. So now regarding the pattern, yes, I'm still speaking. I will mention about the pattern, record pattern, because I'm still discussing the topic of pattern matching here, because JIP 405 is related to this kind of category. So if the subject of the record is new to you, please read about it, and I pretty assume that most of you know about it. But the record pattern comprise of the three components, which is a type, a list of record component, pattern matches, and then an optional identifier. So let's consider, if we assume that you have defined the following point as a record, and then you need to print it, and you can do it like this. So using instance of, so we can ask about the object. If it's type point, we will have the object casted into type point variable, and then we can use point to access its properties like x and y. And this somehow it was like for readability and usability is not that more convenient, and we would like to enhance this. So we need to enhance this to just only access the identifiers directly without using the main variable. So this JIP as of Java 19 allow us to use a new feature called record pattern, which will be rewritten like this. So, and now instead of just having the variable, no, you just say like, okay, if it's instance of this pattern actually, which is point, and the point has integer x and y, and it matches, okay, we don't need to have, pattern like variable to cast for, and it will be explicitly give us an access to directly x and y without kind of any further declaration and access. So much pretty easier and more readable, because record is, a type, and it could be matched with pattern like this much easier. Similarly, it's also previously in Java 17, we have the switch, and the switch statement will be also considering this change, and it will be like this. So previously we have this, we switch over the objects, and if it case point, then we will have to have the point to access the features of the record. But now we can similarly do it like this. Case matching the full record pattern, we will have direct access to x and y. So this is very important change that increase the readability and the quality of our code. So also, what if the record have more record definition inside? So yeah, we could have something like this, a record line, which composed of point and another point from two. And I would like to, do the pattern matching, so we can easily do it like this, using if object is instance of line, and line already have this kind of composition, we can access all the x and y's of each point inside that line in this way. We don't have to have a line and then maybe say line dot point dot x1 and point one and then point two and all of these kind of cumbersome declarations and verbs. So now we can have it easily like this with nested. So definitely if we have it for instance of, then we will have it for switch expressions. So in switch expressions, you will have the case match matching the full pattern of the record, and then you have again direct access to your internal variables easily without the extra variables attached to them. So therefore, record patterns provide an elegant way to access records elements after a type check much more easier and elegantly. And actually, this was all about Project Amber, and this was all the changes has happened to compiler and the language. And now let's move on to Project Loom. Project Loom actually is a very important project because it's designed to deliver a new GVM features and APIs to support easy-to-use, high-throughput, lightweight concurrency, as well as a new programming module, which is called structured concurrency. So the first and most important component that I see from it was long awaiting, and there is a lot of going on changes happening in the GDK in order to prepare for this change, to introduce virtual threads. So there is a lot of changes in IO packages and socket and servers and all this kind of stuff to be ready for the migration. So it's not only your application, it's also the entire GDK and internal APIs need to be ready for this change, because it will be a new paradigm and the concurrency model that we're going to use in future application that will enhance the way that we can debug, and write and maintain and observe these kind of threads, not like the traditional, threading model. This is very important and a very big change happening here, which I like to give it to you. So virtual thread is a preview API. This is because it's big, we need a feedback. So we have to wait for feedback, people to test, and it first introduced in GDK 19. And the goal of this proposal is to enable server application written in the simple thread per request style to scale more with near optimal hardware utilization. And you're going to see this. Enable existing code that uses the current module using thread API to adopt the virtual threads with minimal changes. And even there is no changes, that you're just going to call the new APIs inside the thread API. So you don't need to have another class or something. So it's very easy to migrate. Also, the most important, point and goal was to easy troubleshooting, debugging, and profiling of the virtual threads with existing GDK tools. So they are all integrated and provide easier tools to have this kind of features and functionalities. And also, there is no intention to remove the traditional threading model implementation or even to silently migrate existing application to use virtual thread. If you don't want to move, you can use GDK 19. It will work perfectly with the old paradigm, and there is no problem. If you want to migrate, you have the tools, and you will be very easily migrating without any more changes that you can think about it. So definitely there is no intention to change the basic Java concurrency model. So let's see some examples and history. So one solution has been to use the reactive programming actually to have more threads, but not, actual threads operating system, because they are very expensive to create and you have limitation. Because if you are increasing more than 100 of threads, normally in your application, you will jeopardize the scalability of your application. Then you need more instances. And but you need those threads only for specific functionality and just die. You don't need it for the whole life cycle of the application. And maintaining operating system threads is very, very expensive, and it's not easy. And scalability wise, it's not that scalable. So the solution was to overcome this is to use reactive programming. Reactive programming was like using project like Reactor or RX Java was there, and we can write code like this. So if you would like to create an order, and then you have to create a response of the feared result, because you need to check different components. First of all, you would like to validate, for example, in this example, I want to validate my the request. And then I would like to, if it's valid, I will get the result, and then I would like to enrich the request with some parameters that I would like to introduce. And then after all of this, I want to persist this order finally after enrichment. And if it's successfully done, I would like to subscribe. Subscribe means start immediately the actions that I have described and laid out. And then in case of success, I will have the result. In case of error, I will propagate. And that's the way. But it's nice. It's a good solution, but it's very hard to debug, because you cannot have breakpoints at flat map here or map to see what's happening, because the actual execution will happen upon calling the subscribe method. And this is really only here you can do, but you will miss all the debugging here. So, and this is also a lot of lines and description how the code should be working. But I will lose the opportunity to have the debugging functionality here, and it's a little bit, I see it, it's complex for my eyes. So the solution, actually, virtual thread will allow you to re-implement such a reactive examples quite simply as the following. So yes, like this, because it will use threading inside, and once you have the parent method, it will control all the threads inside. It will be one unit at the end. So in imperative programming style, you can have a debug point and line number 4, another debug point and in line number 6, and another one at 12, and you see finally even here at 15. And whenever there is an error happened in any of these methods, you will, the cancellation will happen. So there is no other method using virtual threads will be, working, because they are considered one unit, and one error means cancel all the others, and easy to debug, easy to read, easy to write, as you can see. So this is a change, and dramatic change in the way that we rewrite, threading modules if we need multiple and unit of tasks to be grouped into one unit. So this is very important change for virtual threads. So, and now we were also thinking about, okay, this is who will benefit more from this, the application servers, the people who are writing the application servers to handle your work, and maintainability of all of this kind of stuff. So for us as developers, in order to simplify the multi-threaded programming module, we also introduced structured concurrency. And structured concurrency actually treats multiple tasks running in different threads as a single unit of work, thereby streamlining error handling, cancellation, improving reliability, and also enhancing observability. And this is very, very, very important. And the structured concurrency is an Incubator API. It's not preview because it doesn't have anything to do with the compiler or underlying. It's only API. So this is why it's Incubator. And any Incubator module will be under the gdk.incubator module dot structured concurrency. And when it is fully production ready, it will be moved to its own, their API with the name. The same like what happens with HTTP client API. It was under gdk.incubator.http. Then when it comes to production, it becomes like java.http.net. So this is how it goes, just for your info. So the goals here is to improve the maintainability, as I mentioned before, readability and observability of multi-threaded code. We will have an example now to clear up this point, and also to promote the style of concurrent programming, which can eliminate common risks arising from cancellation and shutdown. And this is very important. As I mentioned before, such a thread that what to propagate, thread leaks and cancellation delays. And then you can cancel something, but you will have problems, that other threads is still running, and you cannot reclaim all of these threads, and leakage, and you cannot continue like this. How can I maintain all of this? Is maintained by structured concurrency. So let's see an example. You could, but by the way, you can use Java executable framework to write concurrent application as in the following. So I will create executor service. I will create executor service here at line 1, and then I will create same example now, more enhanced. I will create an invoice, and this invoice includes some tasks. One task that will, get the customer by ID. So it's different threads, different microservice. So I would like to get it. So I will return as a future, and I will use executor to submit it. Another one, I would like to get the order by ID. And it will have another thread calling order microservice, and then I would like to in the invoice template, and to get the template for that specific language to be ready. And finally, I get the result for each one of those, and then I will call invoice.generate, submitting the customer, as an argument, the order and the template to fulfill, to generate the final, customer, order, based on this information. And as you can see, executor service use operating system modules, and this is how we can use it. But if I would like to use structure concurrency, you will see that I didn't do any more changes as the coming example. So we can pass 3 subtasks to the executor and wait for the partial result. It's easy to implement the basic task quickly, but consider these possible issues. How can you cancel other subtasks if an error occurs in one subtask? And also, how can you cancel a subtask if the invoice is no longer needed? So you cannot do this with the previous example. And also, how can you handle and recover from exceptions if it happens? One of the services throw an exception. Is it going to propagate and then cancel the others? No, they are running on their own and they have to finish and return back to you. Even one happens. So it's a waste of effort and time and CPU cycle and resources. So all these possible issues can be addressed, but the solution would require complex and difficult to maintain code using the previous executor and feature abilities. In this regard, the solution here is the structure concurrent that take care of all of these previous mentioned points, and then it will give you also easy implementation, which is readable and maintainable for such kind of problems and easy to use. Where is the example? Is it, Mohamed? Here is it. So using the structured task scope, you'll see that I didn't change too much, but just I'm using the new paradigm of the structured concurrency. So inside the create invoice, I will have to have a scope. And this scope, I will create it in the try resource because after shutting down, all these tasks will be maintained under the scope of this structured task scope. And if any single failure happen in one of these, it will cancel immediately the others. If they are continually successful, we will have the final results. So I didn't do anything. The code is similar, and I called scope.fork instead of executor. And here I would like to get, hey, scope, join all of these tasks, monitor them. And if there is any failure happen in one of these tasks in this scope, throw a fail. So the propagation of the errors will be here, and all of these tasks inside this scope will be stopped, canceled, and then you will have an error. This is why then we will catch an exception. If anything goes right, there is no problem. We will reach here at from line 18, and we will get the result, and then we normally generate the invoice as intended. So this is more and more readable, focusing on solving all the previous mentioned problems, and this is the new paradigm to work with multiple unit of work and organized and in organized way. So thank you for structured concurrency to take care of this kind of features. Now, this was all about Project Loom, and now I would like to speak about Project Panama. And if you don't know what is Project Panama all about, it's intuitive, which includes 2 JIPs, 424, 426, we're gonna see now, focuses on interoperability between the GVM and well-defined foreign non-Java APIs. This API often include interfaces that are used in C libraries. So first of all, we have foreign functions and memory API. It first introduced in JDK 17. Tuned introduction, it was in JDK 18, and first as an incubator feature, and now the first preview means there is no further development rather than enhancement and getting the feedback. So the foreign function and memory API enable access to native memory, that is the memory outside of the Java heap. It's very important, and also access to native code, usually C libraries directly from Java. What does it mean? Sometimes we are using big data, and we would like to have and to map large files in certain time for functionality inside the memory in order to read from it, stream it, and parse it. But it's really in terabytes or something. The only solution that I will increase my service if I'm running on cloud, I will pay too much. I will increase the service memory and a lot of scalability that needed at that time, just to not get out of memory for my application that reading that file. The solution is to read this file outside of the main application, and then just when I finished, it's closed. So I don't have to pre-configure my application and service that reading these files with that terabytes of memory, which is useless for me. I just need to run normally all the time. I need 4 giga or 5 gig or 6 giga, but I don't need to have 1 tera of memory, just because in case if there is a large file comes in, I would like to read it. So the solution is off the heap. I read it outside of the GVM, then when I finish, it's done. Native memory. So it's not my application. This will improve the memory consumption footprint for my applications, and it's really easy for scalability. And also, it will not introduce many instances if you are reading huge files in your operating in your services. And you will use the native memory. You will pay as you use, and that's it. So this is very important. And also, it's a replacement also for the very old error-prone Java native API calling that was security leaks, memory leaks, and cumbersome API. So this is another replacement to interact with C libraries, native libraries in the operating system. So let's have an example to understand, but let's see what the goal of this. So Java 19 has promoted the new APIs, I told you, from Incubator to previous stage, and now you know why. And the goal is to introduce a new API for easy access and handle memory segments and functions calls. If you don't follow how the enhancement happened from the first Incubator, I encourage you to read my articles about the hidden gems in JDK 17 and 18, and you will understand the full story about foreign functions and memory API. So a quick example, what if I would like to read, to use some library, and here a simple way, I would like to get the string length of a specific string passed from Java, and I would like to use their len function from C++. So first of all, the foreign function and API and memory, using this code, I would like to call this as I told you. So first of all, I would like to get a lookup object for commonly used libraries. So I have it using simple lookup, and I will call it stdlib. I will use linker.native linker to get the default lookup. So it will be aware of the just default and commonly used libraries in the operating system. We will have access to them. Then I will use method handler using the same linker to have access to the function called string length. And if it's not exist, it will throw an error. If it is, I will use function descriptor, because function descriptor expect a foreign function return type, which will be Java long, and also the return type as the first parameter, as you have seen, with the function argument coming as an extra parameter, which is using addresses. The function descriptor also handles accurate conversation between Java types to C types and vice versa. So this is very important. So since the foreign function API is still in the preview phase, you have to use enable preview flag to run this code. So then I will get now convert Java string to C string and store it in the off-heap memory using memory segment. Then I will call implicit allocator that allocate UTF string, happy Java conference. And then I would like to know how long this string it is. And then I will invoke the method string length, giving the string, and it should finally return to me the actual length of this string. So this was how I can call now native API, even C++, taking the conversion not inside my application, it's outside. So I can read files, I can use the API, I can, for faster processing, for faster accessing, for using native functionalities that I didn't have in Java. So, I don't have to develop them in Java in order to use them in an efficient way and more secure way. And it's pretty easy, as you can see. So this is really was all about foreign memory and function APIs. Let's move to another part from Project Panama, which is Vector API. It was introduced first incubation since JDK 16, and also it's still in incubation until JDK 18, and the fourth incubation still in JDK 19 because there is a lot of enhancement, a lot of porting, things happening in this Vector API. So I will start by dispelling the possible point of confusion because some people get confused. The new Vector API has nothing to do with Java.util.vector class. Instead, this is a new API for mathematical vector computation and mapping to the modern single instruction multiple data CPUs, which short for SIMD. So be aware of this kind of misconception. So Vector API is in the fourth incubation. As I'm telling you, the goal is we have a new development with user model in the API. Developers can use hotspot JVM auto vectorization or auto vectorizer to design sophisticated vector algorithms in Java that are more reliable and predictable. The foreign function and memory API also preview defines improvements to the loading and sorting vectors and to and from memory segments as a part of API proposed for JDK 19. As I told you, yes, we have native access to the memory, so the Vector API make use of the foreign function and memory API to make use of the native, memory in the operating system to allow vector computation and having the return value from outside world of Java. So also along with the complementing vector mask compression operation, Java 19 adds a cross-lane vector operations of compress and expand operations. So there is no code here to show, but I wanted to give you an opportunity what those are. So this was all about the main features come to Java 19. Now let's see what has been improved in the language. As I told you, I'm not going to handle or mention all of these kind of things. But first, actually, it's a JIP. And because, Java is everywhere. And wherever there is a new operating system that we need to support, especially on cloud or something, Java has a port for that. So we have a port, the JIP 422, bring a new port for Linux RISC-V port operating system because it's a free, but it's a widely common used in the community and increasingly popular now. So the JDK has decided to have a port for this architecture with this JIP. So a wide range of language toolchain already supports this hardware instruction set. So currently, this port will support only general purpose 64-bit instruction set architecture with vector instructions and RV64GV configuration of the RISC-V. More may be supported in the future, definitely based on the requests and demands. So the hotspot JVM subsystem that are supported with Java 19 are C1, client just-in-time compiler, C2 server just-in-time compiler, template interpreter, and all mainline garbage collectors, including ZGC and Shenandoah garbage collectors. So now we have a new enhancement here, new properties that for system.out and system.error console. So if you're running an existing application with Java 19, you may see, some explanation marks on the console instead of special characters. And this is because of Java 19, the operating system's default encoding is used for printing to the system.out and system.error. So if that's not what you want, and you would prefer to see output in UTF-8 across all your JVM, so you have to submit this option. while you are running your application or and each application you are running. For each DVM, you have to submit this -d studio out dot encoding UTF-8 and -d studio error dot encoding UTF-8. But what if I don't want to do this for each and every application I'm running on the same machine, and they want to have it globally? So this is the new feature has been added to you to make it easier. So to spread this widely, you can use this option as the environment variable. Yes, it's a starts with underscore, so you have to write it like this: underscore Java underscore options equal the same to argument, and wherever you are running any application, it will be recognized that application and JVM will recognize this environment variable and will start act accordingly to print and use everything in UTF-8. So this is a great enhancement. I like it. So try, if you encounter such a problem, you are welcome to use it definitely. So it's worth to note it. A new methods to create a pre-allocated hash maps and hash sets. So this is really was very important. So because of hash map has a default load factor of 0.75 when it's initialized, this indicates that the hash map gets rebuilt, also called rehashed, with a double the size as soon as it is 75% filled. And thus, for this reason, the new hash map is initialized with the capacity of 180 element can hold only 135, which is actually 180 multiplied by the factor, so mapping without, and it will need to be rehashed if you add more. But initially when we creating it, it wasn't enough, and we are not aware. It's actually create a map not for actual 180, it create a map with 135. So in order to do this, I have to do some math and something like this. So okay, Mohamed, if you would like to have a hash map that will hold 180, I need to divide, this 180 by 0.75, so it will be equal to 240, and I have to supply this number finally, 240, which doesn't make sense for anyone to read if he doesn't know about this trick or conversion, to hold 180 element. So we have introduced new methods, factory methods, in Java 19 in order to make this easier, so you can create your map normally like this. So if you need 180, you will submit or supply 180 as an argument, and it will be understood that I will create a new hash map with this. What happens behind the hood? It will use the normal calculations, and it will, fix it for you. So you don't have to do it in your own or in your head. And similar labor-saving static factory methods have been also created in Java 19 for the others. So the complete set are ready to use this for hash maps, linked hash map, weak hash map, hash set, and linked hash set. All of them have these factory methods for you. Additional datetime formats. Yeah, we have many additional datetime formats, and here you can have your own freedom custom datetime format. So in prior releases only, we have like 4 predefined styles were available, which is full. You can use it with format style. They were full, long, medium, and short. But sometimes I need to be more flexible and have, some flexible style that I would like to do. So in this example, we would like to create a formatter that may format a date according to locale, for example, Feb 2022 or 2023. So in the US locale, and it could be this format in the Japanese locale. So in order to create this custom locale to give us more freedom, you just need to call datetime formatter that of localized pattern YMMM. So it's fully a new pattern of your style. So you don't have only to be limited to format style, full, long, medium, and short, which was predefined for you, and you have no control over the format. So thank you for the new off-localized pattern method to give us the freedom to submit our customized and needed format. So in DeFi, string concatenation, it was actually, this is a bug fix, and you cannot understand how long it was. This bug fix exists in GDK, so it has been solved finally in GDK 19. So in order for some operations. So let's take an example, Java 19, the process of concatenating strings now evaluates each parameter and eagerly create a string from left to right. So confusing you? Let's take an example. So this fixes a bug that we have in Java that was there since Java 9, introduced by by JEP, Java Enhancement Proposal 280, which introduced string concatenation technique based on invoke dynamics. So for example, the following code now prints zoo bar, not zoo bar. So previously, if you are creating a string builder and you have defined a new string builder initially with zoo, then you would like to print that string builder plus string builder.append. So the builder actually will be zoo bar before you abandon, and then it will be printed as a zoo bar. So it's not convenient, but now with the new fix, it will be zoo bar, which will make sense because builder still from the left, it doesn't concatenate yet bar, so it still holds zoo only. And the builder after append, it starts to concatenate bar to the zoo, so it should be zoo bar. So this has been fixed. And by the way, in DeFi is a short for using info dynamic. They are not related, but this is how they announce it like. So it's nothing fancy or something functionality. So those were the most important features that I would like to show you. The others like related to security, related to, you know, GVM more, garbage collectors, enhancement to Java documentation, styling and searching capabilities. You know, it's, so I encourage you to jump into the article and read it. So now we need to know about some important changes that we have to be aware of in favor of migration. So deprecation of the local class, if you are using locale class many times, so the constructor has been gated and marked for removal in the future. Removal means you cannot use those constructors anymore with this functionality. So in Java 19, the public constructors of the local class were marked as a deprecated. And you will get this warning when you have linting. So you should use the new static factory methods because they were error prone and it doesn't give identity equality for this locale. So let's consider the following example and you'll understand me more. So let's have locale of Japanese, which is GA, and another locale of Japan with the new locale GA and GP as a language. So both of those are deprecated and we are creating the same locale but using the factory method of. And when I would like to make equality, that's supposed to be like the first declaration in line number 1 and line number 2, they supposed to be equal because they are holding the same instance. So it doesn't have to have a new instance. But if you trying to test this using this kind of output, try to guess. So the first line and second line will not be equal because they are different instances. While using factory methods, they will equal. Using Japanese one, is it equal? Locale.Japanese, it will say yes, it's equal because it's the same instance, not a different instance. And this is very important, and it was waste of resources. So this is very important, as I told you, because you see the objects supplied via factory are identical and to the local constant, where those created with constructor logically are not because they are different instances. Definitely, we have degradation more and more for straight group methods because this is very important. And it starts from Java 14 and 16. Many thread and thread group methods were marked as a deprecated for removal. And now in Java 19, some has been decommissioned methods, like they doesn't do anything. For example, thread group that destroy invocations will be ignored completely. Is destroyed method will return always false. Set daemon will set nothing, so it has no effect. Get daemon will return the value of unused daemon flags. And suspend, resume, stop, they will throw now unsupported operation exception before they stop, do nothing, and now you don't have to use them. So we will throw unsupported operation exceptions. And this is, very important changes that you have to know about, because all of us may be using threading, and we need to know about all these changes. Those are the major changes happening, but definitely I mentioned more, but it is specialized for a specific group of developers. Those are the most common for cases for any one of us, so that we should be aware of. Reaching to this slide means that I have finished my presentation. I would love to thank you and appreciate your time attending my session. If you have any questions, you are welcome in the chat. And if you previously connected to me, reach me online, reach me through the conference chat, and you are welcome for any questions. I hope that you enjoyed the session and it is beneficial for you. And don't forget, when I share it, go to the articles, read about them, give feedback if you would like, and enjoy it. Enjoy your day and conference, and see you later in somewhere in other conferences. Have a great day. Be safe, guys. Thank you very much.